lesson 36 called Overcoming a Third Obstacle to Factoring. What if there are no real solutions? We're going to take a brief look at some equations and their graphs and what happens when they do not give us the results that we want. So it's a quick lesson. We'll take a look at this opening exercise. We'll answer exercise 1, and then there's some other graphs. We'll probably use Desmos for most of this just to make it simple to observe. But first, in our opening exercise, they do say they want us to find the solutions to each of the systems below by using any method. Since we're talking about using any method, we're going to focus on graphs. And so to do that, and first all we're going to do with this lesson is talk about different graphs, and I just recommend you draw a sketch of what it is that you see. So if we take a look at the first one, right, it says 2x minus 4y equals -1. So that gives us one graph. And if we graph the other one, it says 3x minus 6y equals 4. And what you see is a scenario, and even if I zoom out, the lines do not intersect. They're considered parallel. And since they are parallel, they do not have a solution. We cannot identify any point in which they intersect. So that is the first question in the opening exercise. The second one is going to look like this. If we type in x squared minus 2, we have this parabola. And if we type in 2x minus 5, we have the same idea, but this time we have a line. And again, you can see in these two interactions, they do not intersect. And again, the theme of this section is if the lines do not intersect, they do not have a solution. So one more, right? We type in x squared. Let's see, where's that symbol at? There we go, x squared plus y squared equals 1. So here we have a circle. And if we do x squared plus y squared, and we set that equal to 4, we have concentric circles. Again, a situation where the inner circle never actually interacts with the outer circle, and so what happens is, again, we have absolutely no solution. So let's go back to our notes, and that is right here. So we did the opening exercise, so we'll just put a check mark. Remember, we mentioned that these were parallel lines, so just take a couple notes. These were parallel lines, therefore no solution. This one was a parabola and a line. They did not intersect, therefore no solution. And these were concentric circles. And then, of course, concentric circles do not intersect, so therefore there is no solution. That is the running theme for this lesson, right? They say in exercise 1, are there any real number solutions to the system y equals 4 and x squared plus y squared equals 2? Support your findings both analytically and graphically. So let's say we do analytically first. They tell us that y is equal to 4. So we're going to plug in x squared plus 4 squared equals 2. So you end up with x squared plus 16 equals 2. We subtract 16 to the other side. You get x squared equals -14. And then we square root both sides. And hence is going to become our issue. These cancel. X is going to equal plus or minus the square root of -14. And so where we're at, we're kind of like in the question point of what do I do in this given scenario with that piece. So if we don't know what that does, let's take a look at our graph and let's compare. So we're going to take some of these off. And so they tell us that we have what, y equals 4. So y equals 4. And so that's going to be right there. We'll maybe make that one bolder so we can see it better. There we go. Y equals 4. And then if we put in the circle, x squared plus y squared equals 2, and there's our circle, and as you can see, there is no interaction between this line and that circle. So that creates the problem as to why there's no solution, and the question of why we need to discuss or reason what's going on with that square root of negative 14. Right? We don't have to worry about that yet, but that's coming in a soon-to-be lesson. So next they say in exercise 2, does the line y equals x intersect with the parabola y equals negative x squared? If so, how many times and where? Draw the graphs on the same axes. So again, we're going to use our Desmos just to draw a quick picture of that. So if we have y equals x, right, there's our line. And then if we have y equals negative x squared, we can see that these two do intersect, right? They intersect here at 0, 0, and they intersect here at negative 1, negative 1. So we do have a solution for exercise 2. Now let's say we look at exercise 3. Exercise 3 says, does the line y equals negative x, so we put in y equals negative x, intersect the circle x squared plus y squared equals 1, so we'll put that one in. And we can see that they do intersect. So we would have two very real solutions here and then there. And then for our final exercise in this lesson will be exercise 4. Does the line y equals 5? So we'll zoom out a little bit so we can have y equals 5 on the graph. Y equals 5. There's our line. Intersect the parabola of 4 minus x squared. And then again we can see here that they do not intersect. They do not intersect as they did in exercise 2 and exercise 3. So therefore there would be no real solutions in this particular piece. So in general, that's this section. It was just an examination of how graphs do and do not intersect with each other. And so that is all for lesson 36.